4.5 goes over logarithmic equations and exponential equations. When we are looking at these exponential equations, there are guidelines or steps for solving them. First thing you want to do is isolate the exponential expression on one side of the equation. Then you're going to take the log of each side using the law of logarithms to bring down the exponent. Then you're just going to solve the variable. So what does this mean? If we look at example 2 here, it tells us to consider the exponential equation 3 to the power of x plus 2 is equal to 7. We are going to be solving this. So if we're going to also need our calculator with this. So we have the equation 3 to the power of x plus 2 is equal to 7. Our whole idea here is to take the log of both sides. When we take the log of both sides, we're going to have this log 3 to the power of x plus 2 is equal to log 7. Your rules with logs is if there is an exponent, that exponent goes out front and it multiplies. So we're going to have x plus 2 times log 3 is equal to log 7. From here, you are going to divide each side by that log 3 in order to get the x plus 2 by itself. So we're just going to take the log 3 and divide it over so that way it's not on the same side as that x. So from here, you're going to have x plus 2 is equal to log 7 divided by log 3. Now, if I were you, I would hold off on using your calculator until I get everything on the same side with that log, so that way your x is by itself. From here, we would just subtract 2 from each side, which means in your calculator, you're going to plug in log 7 divided by log 3, hit your enter button, and then subtract 2 from that. So if we use our calculator and we have log 7, close our parentheses, divided by log 3, close our parentheses, we hit the enter button, we subtract 2 from that, and we get that x is equal to negative 0.228756.251. Our directions tell us to round to 6 decimal places, which will be that 6. So this is going to give us an x value of negative 0.228756. Remember, when you're rounding, you are looking at the number to the right of that decimal place value. If it's 5 or higher, you round up. If it's below 5 or less than 5, you keep it where it's at. The next part of our lesson, we are going to be looking at an equation that involves these e's. When we're doing this, for this example, we have e to the power of 2x minus e to the power of x minus 6 is equal to 0. You got to think about factoring with this. So that 6, you have factors. Think of it as a trinomial, okay? That 6 has factors of 1 and 6, 2 and 3. It's a negative 6, so that 1 and the 2 can be negative, making the 3 and the 6 positive, or it could be a positive 1 and a negative 6, positive 2 and a negative 3. That positive 2 and negative 3 are going to give us that negative 1 that we're looking for. So this just factors out to be e to the power of x plus 2 times e to the power of x minus 3 is equal to 0. From here, you're going to solve this the same exact way that you would by solving for or finding the zeros when you are given a trinomial where a is 1. You're going to set each part equal to 0, so you're going to have e to the power of x plus 2 is equal to 0, and e to the power of x minus 3 is equal to 0. And you're going to solve both of these now, working with the one on the left, that e to the power of x plus 2 is equal to 0. Think about these. Get e by itself. Your whole idea is to isolate the x. So we're going to subtract 2 from each side. We're going to have e to the power of x is equal to negative 2. you are going to get rid of that e. By doing that, remember, e is an irrational number. That ln is the inverse of e, and if you have the ln as your base on both sides, it will cancel out that e. So if we do ln to the power of e to the power of x is equal to ln times -2, we are going to cancel these out. This e is also not a power. It's just right next to it. E to the power, there we go. This ln and this e cancels out to where we just have the x, and you can do x is equal to ln times -2. You cannot take the natural log of a negative number though. If you try to do this in your calculator, you would get an error. So for this one, it does not work. However, you can still solve that e to the power of x minus 3 is equal to 0. So move the 3 over, add it to both sides. We have e to the power of x is equal to 3. Again, get rid of that e. Multiply each side by that ln. That ln times e cancels out, so we're just left with that x is equal to ln of 3. Use your calculator, ln of 3, close your parentheses, hit enter. It gives you 1.09861228.9. This does not tell us what place value to round to. However, we're going to round to the 6th place value, just like our question before this that we did. So this gives us an x value of 1.098612. The next part that we are going to look at are these logarithmic equations. So with these, you want to isolate the log term on each side of the equation. First, you might have to combine your log terms though. So think about your rules for logs, or your laws for logs. From there, you're going to write the equation in exponential form, or raise each side of the equation to a certain power. From there, you're going to solve for the variable. So again, what does this mean? If we look at example 8a, we're given ln x is equal to 8. So if I just rewrite this, we want to isolate the x. You're probably thinking ln times x, I would just divide each side by the ln, but you can't do that. You need some ln of something. So again, what's the inverse of ln to cancel it out? E. So you're going to have e to the power of ln x is equal to e to the power of x. That e to the power of ln cancel out, so the only thing you have left is x. And in your calculator, you do that e to the power of x. So if you do your second button, then that ln, it gives you that e. You type in that 8, you hit enter, and it gives you that x is equal to 2980.957987. This again doesn't tell you what to round to. So I'm going to tell you to round to the 3rd decimal place. So that 7. So we're going to have 2980.958. For example B, we are given log 2 of 25 minus x is equal to 3. Now, with this one, you have a base of 2 on that log. So that's going to be your base on both sides. So you're going to do 2 to the power of log 2 of 25 minus x is equal to 2 to the 3rd power. So whatever your base is on that log, if you don't have to combine logs, is going to be the base on both sides, and then whatever you started with becomes the exponent. From here, that 2 is going to cancel out that log 2, so you just have 25 minus x. 2 to the 3rd power is 8, so then you're just solving 25 minus x is equal to 8. I'm going to move the 25 over by subtracting it from each side. So we have that negative x is equal to negative 17. Then I'm going to divide each side by that negative 1. Turns everything to be positive, and we have that x is equal to 17.